In front of us, we have theorem 1.5 of chapter 1. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in form of p by q. So we will take an example. What it says, then x be a rational number and whose decimal expansion terminates. So let's take a number and it must be in form of p by q. So this is a rational number, okay, and its decimal expansion is thus 0.43. Here p and q are co-prime. P is this, q is this. 43 and 100 are co-prime numbers, and the prime factorization of q is in the form of 2 raised to power n 5 power m, and where a and n and m are non-negative integers, means n or m can be 0, 1, 2, 3 up to so on, non-negative or positive integers. So prime factorization of denominator, that is 100, is 2 into 2 into 5 into 5. So the denominator is in form of 2 raised to power 2 5 power 2. So it is in form of this 2 raised to power n 5 power m. So we can say this number has decimal expansion, terminates decimal expansion. Okay. In theorem 1.6, let x is equal to p by x, a rational number such that the prime factorization of q is in the form of 2 power n 5 power m, where n and m are non-negative integers. So let's take an example. Say 12 divided by 2 power 2 5 power 1. Here denominator is in form of 2 power n 5 power m, where n and m are non-negative integers. Now 4 multiply 5, you will get 0.6. So x has a decimal expansions which terminates. Okay, it is terminating. So next theorem is 1.7. What it says, theorem 1.7, let x is equal to p by q. Here p and q are the co-prime numbers. Be a rational number such that they can be and co-prime numbers, such that the prime factorization of q is not in the form of 2 power n 5 power m. So we will take example like 1 by 3. Here 3 is not in form of 2 power n 5 power m, where n and m are non-negative integers, and x has a decimal expansion which is non-terminating, repeating or reoccurring. So when we will divide this number, the expansion we will get is non-terminating, like this, 3 3 is 9, 3 3 is 9, up to non-terminating, repeating. All these numbers will be repeat. So, and we will take another example, 3 by 11. It is in form of p by q. P and q are 3 and 11 are co-prime numbers or rational numbers. The time and 11 denominator is not in form of 2 power n 5 power m. So when we will divide this number, we will get and so on. So this is a non-terminating, repeating decimal expansion. We will use all these theorems in our next exercise. Okay, thank you.
If you find my video useful, for more videos, subscribe my YouTube channel. Go to my website www.hometuitionlive.com. Thank you. Keep learning. Stay home. Stay safe.